everyone! In this video I will show you how to do a truss analysis in SolidWorks. So let's start by doing a part, new, and you will select part. Okay. So you see my mouse, when it's yellow it's just like where I'm moving, and when it's red is when I'm clicking. Click left, left click. First steps, go on the bottom right and change the units for selecting meters, kilograms, second, because the truss is large, so that's what makes the most sense. Move that a little bit. Second step, after I change the unit, save your parts so you don't lose them. Let me do that. Truss demo and enter. So now you should see the name there. One step that I will do before starting the sketch too is I will insert some equation. So you go on Tools, Equation, and I will put as an equation the length. You click Enter. I will put, let's say, 10 meter, 10. You don't need to put the meter because the units are already in meters, and 8, and I will put like 3. So these dimensions, that will be easy to change them because now, let's click on OK. If you see on the left in my tree, I have equation, I have the value there. So I can change them very easily, and I will link them in my sketch. So now I'm ready to do my sketch. So I do sketch, sketch, select a plane on which to create the sketch. So I will select the front plane, and it's important to select the front plane because after that we will use those planes as reference for our study. So make sure to use the same. And I will draw my truss. So my truss, that will be a very simple truss you will see. I put bottom line. Oops, I make it match the center of origin, top, and make sure to close it. And I will add a line from there to the center, and from there to this line. Oops. From there to there, and one from there to there. I will add all the property, but make sure, so I click escape, so I can escape from that. So now I need to put all the dimensions. So just make sure that your points are correct there. Let me see. Yeah, they are attached. Okay. So now I can put the dimension. I will click on Smart Dimension and add the length of the truss. And don't write 10. Click on Equal and select Global Variable Length and enter. So you see now it's 10, and there's a little sum sign in front. That means that this is coming from an equation. Okay. So I have these dimensions, and now I will put also the dimension from the 8. So make sure to select the vertical dimensions. I will click on Equal, Global Variables, and the 8, and enter. So I have the outside kind of shape. Now I don't have any dimensions to add. That will be just properties of my element. Example, I will select the center of origin, the origin, and I will select my line. And I want that the origin is the midpoint of this line. Now my 10 meters length on the bottom is center. And OK. I want this one to be vertical, so I click on it, and I want it vertical. Okay. I know yesterday didn't like it too either. What happened? Let's try it again. Let's make a refresh and edit my sketch. Click on that line and click on vertical. Here we go. It comes. Yeah. Sometimes you just need to click the little light, traffic light, and it helps. And you click on enter. So now it's vertical. Let's click on the little lights just to make sure. Edit. You don't have to click on it. You see now this line is black. So when it's black, I mean it's fully constrained. If I try to grab this point, I cannot move it. But we have these two lines that are still blue. You see this point can slide on that. So for my truss, and it could be different for you, it depends which truss you select. Make another truss with other dimensions, with other shape, other members. But I will select this point and this line, and I want that the point is a midpoint. So this point is exactly at the center of this member. I click enter, and I clicked on the points, and I hold control, and I click on this line. So I can select two objects, the point and the line, and I click midpoint and enter. If you don't remember which properties you did, you can click on the line and you see all the little connection relation. So relation with the points, horizontal. This one you can see the center line, etc. etc. My truss is black. My truss is symmetric. My looks great. I can escape the sketch. Don't forget to save sometimes. Let's save it. I will add the materials before I start the study. That will be easier. You will see the material will be applied right away. So I click right, edit material, and let's select. Doesn't really matter because anyway, we look at the normal axial force, normal force. So that doesn't matter. But let's put stainless steel. What is important is that the material that you select is linear, elastic, isotropic. So same property in all the direction. Apply. Otherwise, that makes something weird with your equation, with your analysis. So we are there. Before we start the analysis, we need to make a 3D truss from that sketch, and we will use the weldment tab. Probably you don't see it, and probably you don't also see analysis. So click right on your tab, and click on tabs, and go select what you need. Simulation, weldment. If you don't see it, yeah, try to get a little bit deeper into the different options. Customize and all of that. But me, I just have it in tabs there. You can also click on this little arrow there and click on customize or see if there's some options that is hidden there or even the add-in. You should be good, but maybe you don't have the SolidWorks simulation clicked. So click on SolidWorks simulation and OK. That will give you the access to the simulation. So you should have weldment and you should have, not analysis, simulation, sorry. So now I can click on weldment and click on structural member. Same thing, it doesn't really matter. I can use ISO, that is the millimeter one. I can use, let's say, a pipe, and I can select 21.3 times 2.3. That will be your outside diameters in millimeters, and 2.3, that will be your thickness of your pipe in millimeter. So I click that, and I will groups. I need to select some of the members. I don't know why you cannot select more than a certain number of members per group. So I will do the outside, 1, 2, 3, and I will click new group. I will click 1, 2, and I think you cannot add the third one. Yeah, you see, you cannot, you just have 2. So you click new groups and the last one, and you click new groups. You absolutely need to have all of them in blue, and you can click on enter. What is happening right now is like instead of being just a sketch, it's a pipe. If you click closer, it's a pipe everywhere now. Okay. So you can save. And we have our truss is now in 3 dimensions. With just a 2D sketch, we were able to have a truss in 3 dimensions. I know it looks small, doesn't matter at all for the simulation because we don't look at the stress inside the pipe, but we look at just the normal force. Now you can click on simulation and we will click on, let me see. Oops, yeah, we can click on study right away. Let's click on new study. And we have statics and we click OK. And we have a lot of different features that came in and we need to go through all of them. So first steps, we click on this little arrow cut list and we will open all the pipes. And this is a good idea to click on them and write on the paper or draw on the paper which one is which one, because we will have to check the numbers after that in the reports of the analysis. So pipe in the bracket number 1, solid body 3 in the bracket number 1, and bracket 3, solid pipe number 4. Anyway, you click right on them and you click edit definition, and you need to change it for truss. Super important. If you don't select truss, you will have a finite element analysis as a beam, and the number that you will get will not be exact. We will not get the same with our calculation. And you see it changed from the beam to truss. The little icon is different. Click right, edit definition, truss. OK. Go open this one, edit definition, truss. OK. Click right, edit definition, truss. I don't. There may be a way to do it them all at the same time. Tell me if you find a way. Put me a comment on the bottom of the video. I would love to know. Truss. And okay, so now all the little different pipes are considered truss for the analysis. Join group. Let's click. Oops. Let me see what we need to do. I click edit and I have these 6 joints. That's perfect. That's what we want. And we click enter. And I will ask you to recalculate them, and you say yes. Here we go. We are done with this one. Connection, we don't need to do anything. Fixture. That will be your pin connections, normal connections, etc. So let's go on fixture advisory. I will open that door a little bit there. I will click on add a fixture. And I will start by this node, okay? So there, because it's not fixed, remember the points to the left, it's a pin connection. We consider that on the left, it's a pin connection. On the right is a normal connection. And everywhere there, we will consider that it's free to slide inside the plane, inside the front plane, but cannot get outside the plane. So our truss doesn't get out the page or the promoter. So first thing you need to do is like use reference geometry. In this blue box, you will select this node to the left, the first joint, and there it asks you for, okay, what is your geometry of reference of geometry of reference? Open your tree and select the front plane. So that means that my front plane is my x and y axis, okay? Same as this one. That's why it's important to select the front plane. It's way easier to manage when it's the same than this referential there. So here, when it's gray, it means it's free to move. So this point, we want it to free to move only on the rotation about the z-axis there. So I need to click on this one left. All of them, they get white. So meaning there's zero translation in any directions. There is zero x connection, x translation, zero x rotation, sorry. And I leave the z rotation normal to that plane free. So my truss can turn on this one. And you click enter. Okay. You click create more interactions, add another fixture. This is the long part. And we will click on use reference geometry front plane. Here we go. Front plane. I think my SolidWorks is having some issue. What happened? Oh no, that's the joint. Sorry. It wants the joint first, and now I can click on the second box and front plane. And for this one is the normal connection. So the translation are on the x is free. So x highlighted gray, so it's free. This one I stop it. This one I stop it. I know it can go up, but you don't want to go down, so you put it at 0, 0. Rotation 0 on x, 0 on y, and the z it can rotate. So here we can slide and we can rotate. And you click enter. Okay, create more interactions, add a support and fixture, add a fixture. We need to add support to all the nodes. Use reference geometry, and I want to select this one, this one, this one, and this one. And I will use the same front plane. And this one, I want them free to slide and free to rotate. So free to slide on X and Y, but not on Z. And free to rotate on Z, but not X and Y. So X, Y. So basically what does that mean is it cannot go outside this plane. It needs to stay in this plane and enter. Be careful for what you do, because if you do something different, it may not run correctly. Now I can go to external load, and you can go back on the advisor, create more interaction, but select add a load, and add a load on the bottom there. I will select this joint. I will select the same front plane, and I will put a force on the Y, and I will put, let's say, minus 2,500. Enter. Oops. What did I say? Okay, I forgot to select the front plane. Here we go. Enter. More interactions. Add a load. Add a load. Let's get on this one. Oh, not the vertex. Sorry. Select the joint first to make sure you select the joint. That would be cleaner. Reference, front plane, Y, let's say minus, I don't know, 5,000. Let's put some weight or some load. More interactions, add a load, joint. The third one on the top, reference, front plane, force. Let's put minus 2,500 like the other one, so that will be symmetrical. Enter. Oops. Oh, it didn't take the front plane. Sorry. Here we go. We take the front plane. And you see, you need to see the three pink arrow. I know they don't grow, but you can see them a little bit more if I do the truss a little bit smaller. And enter. And you should be almost there. So you can click done, continue to the next advisor station, or click on the mesh. So you click right and mesh advisor. That will be the same because that's our next step. And they say no interference are detected in your model. That looks great. And you can click on run the study. Oh, what's happened? Check deformation. So deformation, they give us a very small deformation. That is great. Stress, if I click on this one on the up, I see the stress. So here, it's not the axial load, it's the stress inside the pipe. But what is important to see is it's symmetrical because I put some symmetrical load. So this is the same color on both sides, okay? The deformation, if you click on displacement, number one, double click, this is exaggerated. So it's a scale, you see the scale is there. It's like 150 times the scale. In fact, the displacement is 6 millimeter on a truss that is 10 meter long. So completely, that's good. So the only thing is there, we don't have the normal loads, the tension of compression that we find inside the truss. So to do that, either you can change the results, and I will not do that because I don't remember. Let me see what I say there. Model continuous definitions. Oh, maybe you can select there. Reaction force. No, because it's on the x, y, and z, and us, what we want is in the axial moment. Oh, I have an idea. Let's go on the stress and the settings. Let me see if on the stress I can change. Instead of that, I can click on axial. Yay! But yeah, that will not be the axial load. That will be the axial stress in Newton per millimeter. That's okay. Let me click on that. It was just a test. I think there was a way to find that, but I know how you can do that. You click on report. It takes some time to run the report. You can select everything. We don't need everything, but I will show you what it does give us. And I will click on apply. And it takes some time to build a report with all the different information. Publish. Apply, publish, and you will run your study. I need to check after this, I think a little sensor, little probe that we can find the axial force and not in Newton per millimeter square, but in just Newton. So we just let it run a little bit. It takes 20 seconds. Okay. It's thinking, It could be a good idea to save before you run that, but that's fine. Yeah, probably if you unselect many things in your report, that will go faster. What is important to keep is the tables at the end that give you all the information about the axial force inside each member. We are almost there, and at the end, your reports will open. And so you have your picture, and it's cool because it's a word, so you can add information. This is the truss, blah blah blah, made by what, made by who, for which context. And let me scroll down. So this one is important. You see, you have the. Okay, let me increase the size a lot. Ah, no, I don't want to work on Grammarly right now. Let me go there. I'll show you an example. Let's say this one. Oh, this one is easier. So this is the bracket number 4, and in blue this is this one. So this is this member. This one is number 2 is both of them. So you will have two different value in your report. So ups, what we did, which information we did. This is all the different components. This is the material information, so we don't need that. The joints that we put, the forces. Ups, you have all the information that is repeated. Here we go. We don't need that. There's no reaction moment. There's no, this one is the total of the force, the 2,500 times 2 plus the 5,000. Almost no moments, very, very small because it's a truss. So this is what we are looking for. We are looking for those data. Okay. So this one means in the pipe, in the member number 5, the one that was on the side, remember, the force is 2,430, and you should find exactly the same value. Remember, some pipes have two different members. So for example, number 1 there, you will have one that is 7,000 and one that is 9,700. You should get these exact numbers in your beam, in each members when you do the analysis by hand. All of that should be very, 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 very small. Oh no, this one is, so this one is the stress, the axial stress inside the pipe. Because the pipe is small, very small, the stress are very high. We probably want to have a pipe a little bit larger. But everything else should be zero. No bending moment, no shearing, because we consider this truss, all the member a truss. You can also again see this little graph at the end. So that's it. But for what is important is this one, this table, beam forces, axial, and to find which one is which one and see if it's match your data. So that's it for me. I wish I can check, I can find where is the axial force inside. Maybe there is a way to add a little another probe. If you get it, let me know. I wish I can find so we have it right away and we can add it on the things, but I don't remember right away. I hope that helps. Enjoy doing your truss and doing your analysis. Um, Try to do another type of truss, but make sure it's a truss. And let me know if you have questions. Bye bye.